In this video, we're going to be using an application problem to help us show how we can minimize dimensions. So in this example, we have a rectangular page is designed to contain 48 square inches of print. The margins on each side of the page are 1.5 inches wide. The margins at the top and bottom of each are 1 inch deep. What should the dimensions of the page be so that the minimum amount of paper is used? So note that we have this value here. But our x, if we take, there's two 1.5 inches here, right? So we're basically taking off 3. And then in our y direction, we're losing an inch here and an inch here. So we're losing 2 inches there. So the area to minimize is our x times our y, which is supposed to equal 48 square inches. So let's go ahead and solve for y here. So we'll divide both sides by x and get 48 over x. And that's really not the area being minimized. Those are our inside margins. So that's our inside margins. Our area being minimized is going to be that x, which was x plus 3, because remember our x took off those extra 1.5 inches on both ends. So area equals, and then our y plus 2, again because of that inch on both sides. Now we know what y equals because we said y equals 48 over x, so we're going to go ahead and replace that. So that's going to give us area equals x plus 3, and then 48 over x plus 2. And to make this a little bit simpler, we're going to get common denominators on the inside right here. And so if I multiply this by x over x, I can do that. So I'm going to have area equals x plus 3 times 48 over x plus 2x over x. And now here, notice that I have a 1 over, or I have an x in the denominator. I can pull out a 1 over x. So let's just move this over here for a second. So area equals, I still have my x plus 3, but I'm going to pull out that 1 over x, which is going to leave me with a 48 plus 2x, which I can then rewrite it to be a little more helpful. So x plus 3 over 48 plus 2x all over my x, which was my 1 over x. I just multiplied it through. Now from here, we want to use our graphing calculator. So let's go ahead and let's move this over so we have some room. So we have our equation right there, and we'll pull up our graphing calculator. So we'll clear out whatever's in there, and we're going to go ahead and we're going to put in, oops, wow, there we go. So we're going to put in x plus 3 times 48 plus 2, oops, let's try that again. So 48 plus 2x all over x. If we want to graph this, when we graph it, we're going to notice that we don't really see a lot. So we're going to go into our window and we're going to change our window. And we're going to go ahead and we're going to make our x minimum a 0. And we're going to make our x maximum the number 25. And then we'll count by, let's count by 2's. Our y minimum, let's make that a 0 because we're talking about real stuff here. And we're going to have a y maximum. Let's make that up to 200. And let's count by 20's. Now when we graph this, we can see a little bit more here. Notice that it comes down and then it starts to increase again. I mean, there's probably a slant height there. So we can find the minimum. So we're going to go to second, trace for calculate, and we're going to calculate our minimum value here. So we're going to come over here to the left-hand side. So we move over. Then once we're on the left-hand side, we can hit enter and then go over to our right-hand side. We're just going to get just past that bend. So on the upslope, And we can go ahead and enter to get our value. So we're going to see that we have a 8.48 and an 87.94. And so if we take that 48 over 8.5, because that's what we know what x is, that's going to give us approximately y equals 5.6. So now what we want to do is we want to take that x plus 3 from earlier and that y plus 2, and we want to plug in what our x and y values are that we got. So we're going to take our 8.5 and add 3 to that, and that's going to give us approximately 11.5. And we're going to take that 5.6 and add 2 to that, and that's going to give us approximately 11.6, and both of these are in inches. So the dimension should be 11.5 inches by 7.6 inches.